in person do this in a visual way on the slides, I have a solution of lead 2 nitrate. It's lead 2 nitrate dissolved in water. Formula is shown, PbNO32. AQ stands for aqueous. Similarly, potassium iodide, Ki, and note that both are clear and colorless solutions. But if we mix them together, what happens is a yellow, thick, cloudy substance forms throughout, and if we wait a while, we'll see that this substance gets kind of fine and powdery and settles to the bottom of the beaker that it's in. So the question is, what's going on here? Can we describe it in a chemical manner using a chemical equation, figure out what's going on? And of course we can if we think about it a little bit. So this is example 1. For starters, we have lead 2 nitrate aqueous. We're combining it with potassium iodide aqueous, and it makes some thick, cloudy yellow stuff. And the question is, what is that? And what, if anything, it might the other thing? And these are my cheesy little pictures that help me visualize what's going on. Lead nitrate in aqueous solution, you can largely think of as some lead 2+ ions and some NO3 minus ions in a whole bunch of water. I'm only showing one of each ion. Of course, there'd be many, many, many more. And there'd be 2 NO3 minus ions for every 1 Pb2+ ion. But here, all I'm trying to indicate is what are the substances, not the numbers of them. Same idea for Ki, potassium iodide. The solution would contain potassium ions, K+, and iodide ions, I-, and lots and lots and lots of them. Mix the two solutions together. Remember that these ions are free to move about throughout the solution, and you might notice that Pb2+ ions from the lead nitrate might possibly attract to the I- ions from the potassium iodide. Similarly, K+ might attract to NO3-, and so possible products are the combinations of lead 2+ with I- or K+ with NO3-. It just so happens that the thing that is the actual solid is lead iodide, and the potassium nitrate turns out to be soluble. So how we choose to write that, PbI2 parentheses S, is the product that's visible, the yellow stuff that falls to the bottom, and then we associate the K+ and the NO3- together as an aqueous solution, even though those ions are, of course, really not stuck together in actual fact. And now we notice, of course, we need to balance. As before, you need 2 in front of the potassium iodide and 2 in front of the potassium nitrate. And then one further visualization of how you might sort of see this. Now I'm putting in the right numbers of ions of each thing and allowing them to mix together. And they'll move around bit by bit. And as lead 2+ ions encounter iodide- ions, they'll stick together in a 2-to-1 ratio and settle to the bottom of the container. The K+ ions and the NO3- ions, potassium and nitrate, don't stick together. They stay in solution, but they balance each other out and overall give a net neutral charge to the solution.